Hey everyone, this is Mohammed Nadeem and welcome to my YouTube channel. Today in this lecture, we will discuss about the rules for writing unit symbols and units name. So why this topic? So for that, let's take glance of the previous lectures. In the previous lectures, we discussed about the physical quantities, and the one of the type of that physical quantities is the base physical quantities. And we have the seven base physical quantities. And let's say we consider one of them. So let's say we consider the length, and its unit is meter, and that meter is represented by this small m. So here in these seven base physical quantities, we have this unit name. So this column represent the units names, and this column represent the unit symbols. So we will have some rules for writing these units names and these unit symbol in order to avoid its confusion with the prefixes. As we discussed in the previous videos about the prefixes, let's say in this table we have this milli, and this milli is the name of the prefix. Its value is 10 power minus 3 and its symbol is m. And similarly, we have the symbol for the meter is also m. So if these two are present in the same measurement, let's say if someone say that my measurement is 13.3 millimeter. So here we don't know about which m is used for the milli and which is for the meter. So here this for the meter, this small m is used, and similarly for prefixes, this small milli prefix, this small is m is used. So, in order to avoid this confusion of the unit symbols with the prefixes, we have these rules. So, for the unit symbols, such as these symbols, we have about 10 rules. If you master these rules, then there will be no confusion related to the unit symbols. And similarly, for these unit names, we have four rules. If you master these rules, then there will be no confusion of the unit of the unit names. So let's start these from the unit symbols. In the first rule, they said that the unit symbol are must be printed in the upright form. So here among these three, you will select this upright form, mean that the unit symbol must be in this form. Okay. The second rule here is a multiple or submultiple prefix. Let's say what is mean by multiple and what is submultiple. Here in this table we have prefixes. The prefixes which is positive. So here these are the positive prefixes: 10 power 18, 10 power 15, 10 power 12, 10 power 9, and up to here 10 power 1. These all are the positive prefixes. These are used as a multiplier for the units. So here this prefix is used as a multiplier for this meter, because here this 12 kilometer is equal to 12 with 3 zeros and meter. So it increased the magnitude of this unit. Okay, this prefix increased the magnitude of this unit. Therefore, we call them as a multiplier. And similarly, if we have 12 micrometer, okay, let's say this is about 12 multiplied 10 power minus 6 meter. It reduced the magnitude. Therefore, we call this as a submultiple prefix. So here in this table, all the multiple prefixes are those prefixes which have the positive powers. So here we have the positive power up to deca, and the above all are the multiple prefixes. And similarly, the submultiple prefixes are these with the negative power. So here a multiple or submultiple prefix, if used, is part of the unit. So here this mega is a multiple prefix is part of the unit. what is the unit? So this is part of the unit. It means that you will write this mega adjacent with this unit. Okay. And similarly, and precede the unit symbol without a separator. It means that this mega, this prefix will always present before the unit. It will not present after the unit. If it is present after the unit, it will not make any sense. This rule say that a prefix is never used in isolation. So here, this prefix is in isolation without the unit. Okay, and here this is not in isolation. Okay, so this rule mean that a prefix is never used in isolation. And similarly, the fourth one say that the compound prefixes are never used. 100 nanometer, and this nano is equal to, here from the table, this nano is equal to 10 power minus 9. It means that it is equal to 100, and instead of this nano we will put 10 power minus 9 meter. And similarly, this 100 multiplied 10 power, instead of this minus 9, I will put minus 3 and 10 power minus 6. So 10 power minus 3 plus multiply 10 power minus 6 is equal to 10 power minus 9, and here this is meter. And from this table, this 100 is equal to 10 multiply. So here 10 power minus 3 from this table is equal to milli. So here I'm going to put that milli, and for 10 power minus 6, I'm going to put the micro symbol. So this is micro, and again, this is the meter. So here we have compound prefixes. As this is the milli and this is the micro, and here the unit. So according to this rule, the compound prefixes are never used. So we will not use these compound prefixes as milli and micro for instead of this nano. Okay, so these compound prefixes are never will be never used. Okay, instead of this 100 millimicrometer, we will say 100 nanometer. So here we have the spring constant, which is given by this formula. F is equal to kx, and the k from this formula, which is a spring constant, equal to F by x. F is equal to ma, and this x is actually the length. And here m, the unit of the m is kg, and the unit of acceleration is meter per second square. Okay, and here divided by this L. And similarly, this kg come in its own position, this meter per second square. Okay, so here we have this horizontal line. So for division we use this horizontal line, and as well as we use this solidus line. Okay, per meter square. And similarly, we can use for division this negative exponent. So here this s square is in a division. We use this negative exponent for that. Okay, so this covered this the rule number 7, that division is indicated by the horizontal line or by the solidus or by the negative exponent. And similarly, the rule number 6 indicate us that the multiplication must be indicated by this space. So here there is a space between this kg and this second power minus 2. And similarly, this multiplication is also indicated by the dot between them. So here this is the kg and dot and per second square. So we covered these 3 rules with the help of this example. It is not permissible to use abbreviation for the unit symbols or the units names. It means that if we say that velocity, velocity is equal to meter per second. So you will not show the abbreviation for this as v is equal to m by s. Instead of this, you will use the full name for this as v is equal to meter per second, not the abbreviation. Okay. Here, according to this rule, uh, if the square is present on these multiple or sub multiple with the units, then that square will not present on that unit. It will present on the whole uh, magnitude. Okay. And according to the last rule, if we have the force, the physical quantity, okay, and its unit is Newton, and the symbol for the unit is here is N. If the unit is the name of the scientist, then we will write that unit in capital letter. Okay, so here this is the name of the scientist. Similarly, the Joel is the name of the scientist, so its unit will be in capital form. So the symbol for this unit will be in capital form. Similarly, the hertz. So for the hertz, we will write this in capital form. So here we discuss about the rules for the unit symbols, okay, such like this. And now we will discuss about the rules for the unit names, okay. So here we have these rules. So the unit name are also printed in the Roman or in upright form. It means that if we have the unit of the length is meter, okay, this is meter is actually the unit name, the name of the unit. So we will write this in this upright form, not in this form, this italic form, or in this form. Okay. So we will write this in this upright form, this meter in this upright form. This is also called the Roman form, and you can easily write this in the MS Word. And here there is a option for the Roman type writing. Okay. In English, the name of the units start with the lowercase letter. So here it means that if we have the unit names such as the Newton. Newton is the name of the unit. Similarly, the joule, okay, which is the name of the unit. Similarly, the meter, which is the name of the unit. So here it is. So here, if the unit name is even the name of the scientist, so it will always start with the lowercase letter, not in upper case letter is. So here it means that we will write only the units in the lowercase, and its writing in the uppercase is not allowed. Okay. And here is the exception. Exception is only when the unit name start the sentence. So then we, in that case, we will start the unit name from the upper case letter. Okay. And the second exception is for the title. If the unit name is present in the title, we will start that unit name from the capital letter. So these two are the exception for this rule. And similarly, we have the rule number 3, which is the unit name should be spelled out in full if needed. You do not have to make your own shortcuts for the unit names. And similarly, for according to the last rules for unit names, the combination of prefix name plus unit name is a single word. Kilo is prefix and meter is the unit. These two will be present adjacent to each other. There will be no space between them. Okay, so this will be look like as a single word, not just like this. So there will be no space between this prefix name and this unit name.